The mean waste recycled per person per day is 1.6 pounds. So the mean is 1.6 pounds with a standard deviation of 0.59. So they give you the mean, they give you the standard deviation. Okay, and then they said determine 95% confidence interval for the mean waste recycled per person. Remember that, see, all these questions are real world examples. In other words, when you graduate from, when you finish, you will be, as a statistician, you are actually working with real world applications. Okay, so determine 95% confidence interval for the mean waste recycled per person per day for the population of Maine. Assume the population is approximately normal. Okay, so we are given all the information we need. So we need to list them. So we already know what we are told to find. We are told to find confidence interval. So what are the things that I need? What are the things given to me? So I will start listing what I'm given. I'm given a random sample of 27. This state is state of Maine, but some of them is given to you when you're doing a hypothesis test or confidence interval. Some of them don't even mean, are not included in the test though. This is just to tell you that it is the state of Maine. It can be any other state. Okay, the test is it's about recycling, waste recycled. Okay, and the mean is given to us, X bar is 1.6. We're also given the sample standard deviation. And that sample standard deviation is 0.59. Determine the 95% confidence interval. So confidence interval is 95%, 0.95 for the mean waste recycled per person for the population of Maine. Assume the normal population. Okay, so this is a T hypothesis. I mean, this is T confidence interval. So you want to write the formula even though you can use your calculator, because sometimes you are actually told to find some other things. So the estimate of the mean of the population, we don't know. So we are looking for that mean from the sample given to us. So the point estimate is X bar plus or minus the margin of error, and it is T critical value. Every confidence interval has a two-tailed critical value. Every confidence interval has two-tailed critical value multiplied by standard error. And this is T standard error, standard deviation over square root of sample size. Okay, so the first thing to do is to write the formula, list all the givens, and then try to substitute into the formula. And another question, the first question you're asked to find is the critical value. I want you to remember that this region is called the margin of error, this interval. Therefore, the estimate of the population mean is the point estimate plus or minus margin of error. So the estimate of the population mean, X bar, population mean, mu, is equal to point estimate plus or minus margin of error. Okay, and even though I wrote the formula, but my calculator will calculate it for me, and you are expected to use your calculator. But also you are expected to know what is in the formula. One of the reasons why they want you to know, you see, they ask you to calculate the critical value. So you have to calculate the critical value first, even though you're going to use formula. So let's calculate the critical value, and it is T critical value. So we are given confidence interval of 95%. Therefore, alpha is 0.05. We are doing confidence interval, so we are going to divide alpha by 2. When we divide alpha by 2, it is going to be T alpha over 2, which is going to be area to the left will be 0.025. So I can actually draw the normal curve here. Draw the normal curve. All right. So there are two tails whenever you are doing confidence interval. There are two tails. All right. So the area to the left is 0.025. And the area to the right is 0.025. You are specifically told to calculate the critical value. So you get your calculator. Inverse T, do inverse T. Area to the left in decimal, 0.025. The sample size is 27. Therefore, degree of freedom is 26. Sample size minus 1, 26. Okay, so you pull up your calculator and calculate the critical value. So that's what we are doing right now. Pull up my calculator, calculate the critical value for this. Before I do the confidence interval, I have to calculate the critical value. So second distribution, inverse T is number 4. And area to the left is 0.025 because it is confidence interval. So, and degree of freedom is 26. Sample size minus 1. So I'm going to paste. Therefore, the critical value, negative 2.06. The critical value on the left is negative 2.026. And I hope you know that, still remember that T curve and normal curve are symmetrical. So on the right, you have 2.06. So 2.06 plus or minus. You can actually say that the critical value T alpha over 2 is equal to plus or minus 2.06 because there are two of them. It's two-tailed. Now you are ready to do the calculation. I like to draw a number line and put the point estimate here and put the upper bound. The upper bound is margin of error to the right. Upper bound is margin of error to the right. The lower bound of my confidence interval. All right, so now I calculate, pull my calculator up and do the calculation. So now I am calculating the confidence interval. That is T confidence interval. So go to Start, arrow to Test, and I'm doing T confidence interval. Let's make sure we get the right thing. So go to Start, arrow to Test, T confidence interval. So we're going to look for T confidence interval, T interval. T interval is right here at 8. And I'm given the stats. The sample mean given to me is 1.6. The standard deviation is 0.59. The sample size is 27. The confidence level is 95%. And I'm going to calculate So I see that the lower bound is 1.37 and the upper bound is 1.83. So 1.37, 1.83, 1.37 are here, and 1.83 is right here at the right. And then if I look, I will also see, remember that it is, I'm estimating the population mean. I already have the sample mean, the point estimate. Point estimate is given to me 1.6. So I am also told to find the margin of error. Find the margin of error. In other words, find what is this? Find this margin of error. Okay, the margin of error is upper bound minus point estimate. So 1.83 minus 1.6. So the margin of error is 0.23. 0.23. So this distance is 0.23. 0.23. And this is also 0.23. Therefore, you make a decision, because this is a real world question. So you make a decision. Make a decision. Therefore, I am 95% confident that the mean of the population mean, that mu lies between the upper bound and the lower bound. Lies between 1.37 lower bound and 1.83. You cannot be more confident than the confidence level given to you. So I am 95% confident that the mean of the population lies between the lower bound and the upper bound. Another way you can write it is, you can write it this way. You can say that mu, the population mean, is equal to the sample mean 1.64, 1.6 plus or minus the margin of error 0.23. This is the same as mu is equal to point estimate plus or minus margin of error. Okay, so you make sure you explain this to those who hired you to do this investigation. See that this is a real world example, and this is the kind of thing somebody employs you to do as a statistician, and when you finish they will pay you. But so remember, you have to explain to them your findings in real world. Make sure in a layman's language. You are not going to be speaking a jargon, any jargon to them. Make sure you speak what they understand. They don't know it, that's why they hired a statistician. So, and you must be confident to the level of confidence you are allowed to use. 95% confident. Okay, so you are 95% confident that the mean of the population lies between the lower bound of your calculation, 1.37, and the upper bound with a margin of error of 0.23. So you don't know, you're trying to say that you don't know what the mean of the population is, but you know that it's going to lie between the lower bound and the upper bound. Okay, so that is the example on confidence interval. So today we have done two reviews. Remember that this is a combined review